Hi everybody, it's Ms. Shafiq speaking here. I hope you're all well. Today's lesson is going to be about the Triweekly review. Now unfortunately I can't be with you for a live lesson, but hopefully this lesson that is going to be presented for you is going to help you to understand a few things that you might have found tricky in your Triweekly. So before we start, you're going to need your science book. If you have left your science book in school or you've run out of space because you've finished your book, then you can use some paper if you want to, and you're also going to need your stationery equipment. This lesson is going to take you 1 hour at the most, and if you have any questions you can email me on the email address that I've written on class charts. So what are today's lesson objectives? So what we're going to do is we're going to review the Triweekly assessment. We're going to recap some key ideas including definitions and units, and we're going to go through questions that the whole class found quite tricky. But before we get on to all of that, here is a do now task for you to do in your books. So what I'd like for you to do is to pause the video and attempt as many of these questions as you can, and when you are ready, press play and we'll go through the answers together. Okay, so I hope you've had a chance to attempt as many of these questions as you can. Let's go through the answers together. So question number 1 said, what is the law of conservation of energy? And a number of you actually mentioned the answer to this in the live lesson last time. So the law of conservation of energy states, I'll write the answer at the bottom here, that energy cannot be created or destroyed so here we go, energy cannot be created or destroyed, it can only be transferred. Well done if you got that one correct. Question number 2, name 3 different forms of energy. There were so many you could have written for this one. I'm just going to pick the 3 that I thought of. So we've got chemical energy, one that I thought of light energy, and I also thought of gravitational potential energy. There are a number of different ones that you could have written. If these aren't the 3 that you had, you could have written elastic energy, you could have written thermal energy. Any 3 would have been absolutely fine. Right, question number 3, name 2 energy resources that don't use the sun as their energy source. So if you remember from the live lesson that we did, there were 3 possible answers we could have written for this question. The first one begins with T, it was tidal. The second one begins with N, it was nuclear. And the third one begins with G, and it was geothermal. So well done for everyone for getting those ones correct. And then finally, question number 4, a runner uses 10 J of energy. What does the J stand for? And we know that J is the unit for energy and it stands for joules. So well done if you got those correct. Give yourself a massive tick and a huge smiley face in your books, and let's go on to the next part of the lesson. Okay, so you might see some ticks and crosses in front of you and think, what on earth is Miss Shafiq showing us? But I thought you'd be interested to know that this is what I see when you do your Triweekly assessments. So these are all the marks that you would have got for the different questions. So you can see that I'm writing at the top here, 9, 10. So for example, this column here would be for question number 11, this one for 12, this one here is for question number 13. So you can see from the Triweekly, everyone found question number 3 really tricky. But then you can see question number 12, which is here, that everyone got that answer correct. So what I'm going to do with you is I'm going to go through some key ideas that everyone found really tricky based on what I can see from the Triweekly scores that you've got. And those trickiest topics, the ones that you found the hardest, were included things like definitions, units, and power. So that's what we're going to focus on today. Let's start by looking at energy. From our do now task, we said that energy can take many forms. And if you remember from the 3 examples that I had, I wrote we can have chemical energy. I've forgotten what I've written now, but let's just do some other examples. You can have light energy, you can have thermal energy, you can have gravitational, yeah. You can have elastic, so things that stretch are going to have elastic energy. You can have kinetic, which is movement, and there are a few others as well. So energy takes many different forms, and we said that energy can't be created, it can't be destroyed, it can only be transferred. So it changes from one to the other. So I'm just going to give you 2 minutes. You can pause the video if you need to copy down the information on this slide and press play when you're ready. Okay, so what are the units for energy? And again, we did this in our do now task. So the unit for energy is joules, units for energy are joules, or capital J for short. So be very, very mindful of the fact that it's a capital J and not a lowercase j. Or you might lose some marks in an exam if you wrote the lowercase j. So in a sentence, you could say, Bob has 100 joules of kinetic energy. Bob Jr. also has 100 joules of kinetic energy. So that would be how you would talk about how much energy the individuals have and how you use joules in a sentence. So I'll give you 2 minutes again. You can press pause if you need to copy down the information on the page, and then press play when you're ready. So we've said that energy can take different forms. So we've got chemical energy, for example, we've got light energy. How does this link to power? Now, power is how much energy is transferred in a given time. So for example, seconds. And what does this actually mean? So I'm going to draw some pictures of Bob on the left here and Bob Jr. on the right, and you're going to be super impressed by my artistic skills. This here is Bob, and this is Bob Jr. He's taller than Bob for some reason. And if Bob is running, he's got 100 joules of energy, and he uses that 100 joules, he transfers that 100 joules of energy in 1 second. We say that Bob has a power of 100 divided by 1, which equals 100. And the units for power are watts, which is a capital W. Now let's look at Bob Jr. here. Now Bob Jr. is a little bit slower. So when he is running, he transfers 100 joules of energy, but it takes him 10 seconds to do this. So if we calculate Bob Jr.'s power, he uses 100 joules of energy, so 100 goes at the top, in 10 seconds. So we've written divided by 10. And 100 divided by 10, that gives us 10 watts. So you write that as 10 W. Now, we can explain what this means by looking at how much energy is transferred, whether it takes a long time to transfer that energy or a short time to transfer that energy. So if Bob has 100 joules of energy and it only takes him 1 second to transfer that energy, he's going to be quite powerful. However, Bob Jr., he's also got 100 joules of energy, so they've got the same amount of energy, but it takes Bob Jr. 10 seconds to transfer that energy. So Bob Jr. isn't quite as powerful. So when we talk about having a high power means you can transfer the energy in a really, really fast time. So in an exam, if they ever mention energy and time together in a sentence like this, so for example, they might say certain amount of energy in a given time. So they've mentioned energy and they've mentioned time, or they might say alternatively like 100 joules of energy. We know joules are what energy is measured in a time of 3 seconds. So in both of these sentences, we can see that they've mentioned energy and time. That means they're talking about power. So it's kind of a clue for you. So any time they talk about energy and time, then that means it's linked to power. So what are kilowatt hours? Now, kilowatt hours are a measure of how much energy is transferred. So it's most commonly seen on an electricity bill. So what I'd like for you to do is I'd like for you to pause this video and copy down the information on the slide in front of you, and then I'll give you an example of what kilowatt hours means and how it's used on the next slide. So press play and you may continue when you are ready. Right, so kilowatt hours. I said to you that I will tell you an example. So if your electricity bill showed that you used 36 kilowatt hours, that means 36 kilowatts of electrical energy was transferred to your things in 1 hour. So kilowatt hours always measured how much energy is transferred. Okay, that's not to be confused with joules. Joules measures how much energy something has. Kilowatt hours are the units for how much energy is transferred. Okay. So we learnt about energy resources in our live lesson, and I know there are quite a few things that can get confusing. So we've talked about energy. The units for energy are joules. We've talked about power, which is how much energy is used in a certain time. And then we've talked about kilowatt hours, which is just a unit, kind of like how a centimeter is a unit that we use to measure something. Now what we're going to go on to next is an energy resource. So you may remember from our live lesson where we had to unscramble the letters to find out what the words were. We learnt about energy resources, and a resource is a source of something that can be used for a specific purpose. So if I have an energy resource is something that has a form of energy that we can use to make electricity. And an example that you'll be familiar with is fossil fuels. So we know fossil fuels are a energy resource because they contain chemical energy. Okay, so pause this video and copy down the information that you can see in front of you, and then when you are ready, press play and move on to the next slide. Okay, so I'm just going to give you another example of an energy resource. So solar, for example, we did this as well. If you remember solar bears, you don't have to copy this information down. You've already got it in your book. So we said that energy from the sun, heat and light reaches the earth and is used to heat water or make electricity. So this is another example of an energy resource. Okay, so let's recap what we've done so far. So we've said that energy can't be created or destroyed. We said that power is how much energy is transferred in a certain time. So if you can transfer energy in a really fast time, that makes you super powerful. If you transfer energy over a long time, that makes you less powerful. And we also said that an energy resource has a form of energy that we can use to make electricity. Phew, I think that's that. So what I would like for you to do, I'm just joking, we're not finished yet, What I would like for you to do is please copy the information that you can see on the page in front of you, and you can pause it and press play when you're ready to go on to the next slide. Now, another thing that people found very tricky when they did the tri-weekly assessment was units, and what different units are used when we're talking about energy, what units might be used when we're talking about power. And so I just wanted to give you a table that shows you how we can use the information from the energy topic and put it into a table that will help us remember the different units. So I'm going to start with a table that's got things in it that you're already familiar with. It's got nothing to do with energy, but it's just to give you an example of the different units we use for different things. So as you can see here, if we have a distance, so if I want to measure the distance from my house to your house, for example, then I can measure that in meters. And instead of having to write out the whole full word meters, I can just use a little m for short. So an example of this, if my house to your house is 15 meters, I can write 15m, 15 meters for short. Okay. Right, now for time is a similar thing. So if I time how long it takes for me to walk to my neighbor's house, I can time it in seconds. And the full word, obviously, you can see in front of you is written as seconds, but instead of having to write the full word, I can just do a little s for short. So if it takes me 5 seconds to walk to my neighbor's door, I can just write 5 with a little s. And similarly, force is measured in newtons. So you can see the full word there, it's written newtons, but instead of having to write out newtons, that's going to take me ages. All I need to do is just use a capital N. So if I've got a force and it's a very strong force, I can write, for example, 1,000 newtons, and I can just write a capital N instead. Now, in the energy topic, you can do a very, very similar thing. So if we have a look at the second table, we can see that the unit for energy is in joules. So here's the word joules. And instead of having to use the word joule when we write it, we can just use a capital J for short. So just like Bob had 100 joules of energy, we can just write 100 J, and that tells us how much energy Bob had, 100 joules of energy. Now the units for power are watts. Okay? And instead of having to write watts, so this is where we're looking at the moment, instead of having to write watts, we can just use a capital W for short. So if a kettle has a power rating of 60 watts, then we can just write 60 with a W after it. And if you remember what we said about power, that means that the kettle will transfer 60 joules of energy every second. That's what 60 watts means. Now time, we've done time twice for some reason. Time, full word, you can write seconds, or for short, you can just write S. So let's say 5S. And then for energy transfer, so how much energy is transferred, like we have on our electricity bills, instead of writing the whole long word kilowatt hours, you can just write kWh. And the way that it's written is very important. So the K has to be lowercase, the W has to be capital, and the H has to be lowercase as well. So for example, you might write 12 kilowatt hours. Okay, so copy this information down and move on to the next slide when you're ready. Okay, so for one of our last slides, what we're going to look at is what the kilo means in a lot of our units. So on the previous slide, I said that you can have kilowatt hours. And what we're going to look at is we're going to focus on this K, which stands for kilo. So for the first question, what I'd like for you to do is you don't have to write anything down just yet. Have a think about it. If a person has 10K, what does the K tell you? So you can see there's a pound symbol there as well. If a person has 10k pounds, what does that k tell you? Have a think about it. Once you've had a think about it, write down any ideas that you might have in your book. Okay, I'm pretty sure that all of you already know this. So if you see in a question, or if someone says he's got 10k pounds, then this k tells us that he actually has 10,000 pounds. Okay. Right, so for the next question, same thing. If a person has 20 kilojoules of energy, what does that K tell you? Okay, have a think about it. Write down any ideas that you've got in your book. What does that K tell us? If a person has 20 kilojoules of energy, what does that K tell us here? Okay, so just like in our example before, anytime you see that K, it means there's 1,000 involved. So if a person has 20 kilojoules of energy, what that means is he has 20,000 joules of energy. Okay, so 20 kJ means we've got 20,000 joules. Okay, let's do another example using watts. Okay, so if an electrical appliance has a power rating of 30 kilowatts, what does the K tell you? I'm pretty sure you're going to be seeing a pattern now as almost as repetitive as the guy who was eating the crisps on the video that we saw. Thank you very much for that, by the way. I ended up having loads of crisps after that lesson. So, if an electrical appliance has a power rating of 30 kilowatts, what does the K tell you? Okay, so we know that 30 kilowatts, the K tells us that this is in fact 30,000 watts. Okay. So I've put a time of 5 minutes at the top. If you want to write down the sentences that I've written, the questions, then you can write them down as well. If you think it'll help you, just to have a recap for next time, and you can highlight it so that you can see it when you come back to revising the topic. So take a couple of minutes if you want to copy down the information on the slide, and then we've got one slide left before the end of the lesson. Okay, so finally, what I'd like for you to do is just to write down in your books the answers to these 4 questions. So you don't have to write a long answer, you can if you want to. I just want you to tell me if you feel like you understand energy a little bit better after listening to this lesson. I want you to tell me if you feel like you understand power a little bit better. Do you feel like you understand energy resources a little bit better? And do you feel like the units kind of make a bit more sense now? Okay, so I just want you to answer these 4 questions in your book. Be as honest as you can. So if you still find it a little bit tricky, that's absolutely fine. If you feel like, I really understand it better, then that's absolutely fine as well. Be as honest as you can. And once you've finished with that, that's the end of the lesson. So don't forget to take a picture of your work and submit it on class charts at the end of your lesson. You guys have been really, really good, and I've absolutely loved having to check your work and chatting to you in the live lesson on Tuesday. So I hope you have an absolutely lovely, fun and fantastic half term, and I will see you when you get back. Okay, bye.